Hello everyone, thank you for joining my talk. My name is Maximilian Schattauer. I work at Parallel in Munich as a technical consultant. And today I would like to present to you a short result of investigations that we did at our clients with regards to semantic retrievers, or basically what is coming beyond it. Namely, how we can not only leverage embedding models, keyword-based methods, but also LLMs that we prompt in order to get more satisfying results with regards to retrievers. Let's first look at the challenges of conventional retrieval setups. So what usually happens is that a user of a retrieval system, in order to get a set of documents out of a corpus, forwards a query that they want to query documents about to a retriever. This retriever then goes through a corpus with the help of some kind of search or embedding model and retrieves documents that fit to this query best. So in case of an embedding model, that would be with regards to semantic relatedness. With keyword-based models like BM25, that would be kind of the congruency of keywords between the query and documents. And then people end up with a set of retrieved documents with the amount that they like. And either they can use it with LLMs, but they can also, and this is the important case here for us, not use it with LLMs, but for example, present it to the user, use it with some downstream data application. The challenges that come with this setup are that you always need to take into account the entire query when you do the retrieval process. So you cannot focus on certain aspects or add in a certain focus on some part. It's always a black box that you cannot really control with this conventional retriever setup. And also, there's no reasoning process behind this. So that means that the order of the documents, or the one that is favored the most by the whole setup, cannot be influenced by a reasoning process. And this might be of interest if you have some very specialized domain where either semantic models or keyword-based models break down because stuff is too similar for these models. And then you would need a reasoning process to find minute details in the differences between the documents and then use that as a basis for reordering. And we at Parallel were confronted with such a case at one of our clients recently, and we saw in the quantitative quality of the retrieval results, that we cannot just make do with this kind of setup. We would need to use an LLM in the retrieval process to make it more fine-grained and have more fine-grained control. So what we did is that we used the setup that I just presented, so feeding a query to a retriever equipped with corpus and embedding model, to only get preliminary documents. So with a classic retrieval process, you would get a preliminary set of documents, but then you would leverage an LLM to refine the set and refine the order, and then end up with the retrieved documents that you're actually looking for. And the nice thing about this is that it offers an additional text input dimension where you can refine aspects, you can add metadata to your documents at this stage that you want to be leveraged or that you want to be considered during the re-ranking process. So this enables us then to now use reasoning. So you can either use a normal LLM or even a reasoning LLM to reorder your documents, and you can inject other aspects like metadata, rules, for example, also that could not be captured by a classic non-LLM retriever model. And now looking into the detail of how we actually did this, we actually used the LLM not just as a one-off re-ranker, so putting all the documents into the prompt and then having it select from them, but we used the LLM as a binary document comparator. So what we did is we put two documents into a prompt and a query, and then asked the LLM, this is the domain, look at the following two documents, look at the query, which one do you find more suitable to answering this query? Please give me an answer, either A or B or left or right, or up or down. And what we end up with by doing this for all combinations of documents is a matrix. that compares all the documents by verdicts of the LLM. And then you can see, for example, that document 2 is more suited than document 1, and document 3 is then less suited than document 1. And with this, you can establish an order of documents in the end. Especially if you use the LLM multiple times at a non-zero temperature, you can get some statistics to ground this ordering on, and then you can basically count the verdicts and order the documents by that. And we found in our project research that this is more reliable than a one-off invocation, especially if you're dealing with many preliminary documents, because you would end up potentially with the needle in the haystack problem, and documents would get lost in the LLM processing. And this way you have more control of this re-ranking process. But, and that is to be considered as well, runtime and costs are of course an issue here. So this takes way longer than just a one-off LLM comparison or even a classic retriever setup alone. And yeah, the incurring costs are of course also higher than if you just use an embedding model or even a keyword-based model, because you have to do many, basically on the order of the square of the number of documents, LLM calls. So what is our take-home message from this anecdotal talk about one of our projects is that we have seen that conventional retriever setups do have difficulties, especially with specialized corpora and retrieval tasks with special needs, like certain aspects, certain focuses to pay attention to. And we recommend LLMs as re-rankers in this case in a binary comparison setup, as I just explained, because we have seen that with just comparing two documents, the results are quantitatively better than with one-off LLM re-ranking setups. So thank you for listening, and looking forward to the other talks.